switch the... Okay. Thank you very much. Thanks to the organization to have invited me here. And I was very glad to follow this conference where I could learn a lot from many of the speakers which came before me. And because I know I come from a small country compared with your country. We are only 60 million, a little bit less than 60 million, so we are nothing compared how many you are here. And of course issues are totally different. And because as a company we want to be able to serve our technology worldwide, we need to learn which are the real issues in different countries around the world. I try to pitch here on just on one picture what we offer as a contribution in this section. When we talk about machine-to-machine, we have everything in the cloud, and for us, machine-to-machine is not just taking data from a sensor or for a machine or for a device. We know that we have to provide also machine-to-people type of services. Otherwise, getting data, collecting data, will be just a cost for everybody. In the last decades, we collect so many data that we got the problem of big data. So we create big data issues by ourselves. So we have now to manage big data problem just because we grab data everywhere. But between these zillions of data, few of them are really useful and available to the people. My speech here is focused on platform infrastructures that you need in order to be able to manage effective machine-to-people type of services. And we as a company, just a few words about us, as a company, we are focused on delivering such a type of technologies to anyone who wants to build and implement his own mobile machine-to-machine or machine-to-people application. So we don't, let's say, build application by ourselves, but we give the technology to anyone. It can be telecom companies, can be private companies, can be institutions. A few words on the company. I opened this company a few years ago inside the campus of Politecnico in Turin, so it's like this place where we are. And still that we are not a startup anymore, I kept my headquarters over there. The beauty is that we are all the time binded and in contact with professors, researchers, new students, and we spend a lot of money doing research together. So this is a strategic, let's say, alliance. We work with many other universities in Europe and North America too. Hopefully we can have also some relationship with the campus here. Another point is, as I said before, we don't do business directly, but we give our technology to other companies. And we support companies, private or publics, to build what they need for their own users. Now, let's go straight to the point here. There is a big trend in the marketplace. It's been already pitched by other speakers before me. But again, the big demand is not just gathering data. We are able to do it since 1 decade at least. The real challenge here is to give new services in multiple sectors. Just to mention a few of them where we have quite good experiences. Intelligent transport system is a big area. We had a speaker before. We can manage through our technology every infomobility type of services to drivers. We could support traffic management and road management. We know which are the problems in the urban and suburban areas, which are totally different compared with the interurban areas. We work in the home automation. We have in our booth here, we have a nice demo where you can look how we can grab and show information taken online from the sensors we have here. We work in healthcare, especially for the mobile healthcare, which is a new frontier. And of course, energy, manufacturing, and environment. So those are the 6 sectors where we are active, at least where we have experience through partners, or in few of them, and on some projects we are also directly involved as a supplier. So first point is to deliver services to people. Second point is to be able to integrate the business process model of business to consumer and business to business type of services, because data that you get from sensors can be very useful even in retail. If you get information from inside the store, when your consumers come to the store, we can offer a very nice user experience, just automating what is inside the store. You can switch on lamps, lights, you can start some specific around me services, and this is just an example. So we have to be able to integrate data in different areas. Smart buildings is a typical example, and smart cities, which is a very broad type of project. We are inside the Turin Smart City project. Is still a research project, because we are trying to figure out which will be really smart for the people. Third issue is to link and integrate different suppliers. When we talk about machine to machine, there are many different devices, networking, and so on. We will see in the next slide. And what is also a new frontier is the remote and mobile monitoring and control, which can give a lot of benefits to the people, either professional or private citizens. Of course, there are a lot of issues. Remote mobile monitoring and control means that you have to be device independent from the user point of view, so you should deliver your service on any device, for example. And you have also some security and redundancy issues to support business continuity, process continuity, if you are in the manufacturing, for example. What bMooble research says, bMooble is a major authority in this field. They are based in UK and in Cambridge, Massachusetts. They give us a lot of reports about the trends of the machine-to-machine market. So I will invite you to look at this bMooble research website. What they say, to reduce time, costs, and have affordable solution for machine-to-machine, you must need a platform. You must have an architecture behind you. Now, this is simply the framework where we work on. So we have the first level is simply sensors, actuators, Internet of Things. So anything that is around. We don't deal with this level at all. We don't provide sensors or machines. Then the second level is the field networking. So here again, there are a lot of technologies around, from Zigbee to Wi-Fi to radio frequency and so on. And then the next level are the hardware interfaces, which are placed in the field. If you go in manufacturing, those are the PLC of the machine. If you go inside our type of applications, those are specific interface like data logger, able to collect data through the local network from the sensors and machines in the field. Now, we start from this level. We are able to put embedded software in this type of electronics. And we are also able to provide as a sample some electronics devices in case you need to run a prototype, we have a nice rapid embedded prototyping tool. And we can give this type of electronics where you can flash assembler generated by the system according to the logics that you have designed using a model. Why is it important to bring logics also at this level? Because sometimes if you want to keep redundancy, you want to offer process continuity in the field, you must think that internet could be broken at a certain point in time. So this area here is not reachable anymore from outside. So you must deal with the risk. Going up, there are gateways, okay? There are tons of different gateways around. And at the end, we have a platform. There are many different platforms around. Many of these platforms, they just collect data, are very good to collect data. But now we need also a platform who is able to deliver services. Now, in our technology, we can do both. We can collect data, we can deliver services, because on the platform itself, you can define the logic you want to apply. The logic could be a logic to manage machine with machines. You can have a machine who is talking to another machine. So the logic itself will generate a process which is an asynchronous process. But you can also define logics for machine to people. So what I want to offer to my users, because the users, they want to monitor something, look at some results, but they can also interact with the machines, to switch on, off the light, to switch on the heating at home, or to control a machinery in the plant during the night. Now, I try to go faster through my presentation. I think all the PowerPoints will be available to anyone. Innovation we do, modeling your environment first. You have to decide where to put the logic. The logic cannot be just in one place, as I said before. So we are working on distributing computing inside machine-to-machine platform, which helps you to bring more value, more security, more flexibility to anyone who wants to build their own machine-to-machine services. Move monitoring and control logics as much as you can in the cloud. You cannot just put everything in the cloud. But as long as you don't need to have logics in the field, and you are able to take it in the cloud, you have immediately a lot of benefits. I will present 2 showcases later. Simplify big data management. Instead of just grabbing data every 10 seconds, you can just work on the differences. Means if the temperature is always the same, and you can establish a range, and you have also to couple with errors and error propagation in measurements, you don't need to collect the data every 10 seconds. You collect just when something changes. And if the temperature is stable, you get few data in 24 hours. So you can really shrink down what is the big data problem. Of course, you must change your mind. Instead of applying linear equations, you must work with differential type of computing. Logic distribution in the field, rapid embedded prototyping, and testing. So this is the full approach that guides you to come with a at least controlled environment. Those are most points that we covered already. Let me just go to talk about 2 examples we did. This is a big plant inside a company. They do tires for cars. This is a simple tube, 15 centimeter diameter, where there is a raw material flowing in. There's a powder. And we have been asked to understand how the physical phenomenon works inside, because sometimes the tube is stuck and they have to screw it down and clean it. Now this tube is almost 1 kilometer long and is 50 meters from the ground across many different plants of this big industry, and is a critical type of plant. So what we put some sensors on the tube from Siemens, but we have not been able to find a data logger able to be managed remotely, because when we want to measure something that you don't know, you must at least be able to change the frequency you read the data. And if you want to change the frequency, you cannot just go every time 50 meters on the sensor side, which is very complex stuff to do. So we build with our electronic sample these connectors, which are data loggers, and meantime, they make also time synchronization. Because what we wanted to do is to find out the right frequency, which is 20 Hertz, after which we changed it many times. We found the right frequency to measure the speed of the powder inside the tube. Measuring the speed of the powder inside the tube, we can have a nice information of the efficiencies of the plant. And we had to, of course, to give the time, the precise time on each data. Collecting the data here, we are able, of course, to understand how the efficiencies of a plant goes. And the efficiency is related to external factors like temperature and humidity. So we send alerts, not just because we have a threshold, but this threshold depends from external functions. So everything is very nice designed and built. So the companies now is able to increase the efficiencies of a plant, and they get exactly the right alert when the plant is losing efficiency. Very fast. This is another one. And this is a more complex in terms of grabbing data and analyze data. Yeah. This is how to manage an entire energy cogeneration plant based on fuel cell, hydrogen fuel cell. Those are some examples. This is the sample, electronic sample that we do, for example. And we can, we could manage the entire system. You know, what you have on mobile, for example, is a nice interface. Okay, we have been recognized in June from an Open Alps organization. Open Alps, those are the different countries on the Alps. So we have French, Germany, Italy, Austria, and so on. And we have been a winner for the Open Innovation. We are inside many different organizations, nationals and internationals. And at this point, before I close my speech, I want to thank all you, not only as a persons attending the company, but all you as a nation, because this was my first time here in India with my partners from Bangalore, so they teach me a lot, but really was very, very important to see your real life. And I had a lot of opportunities to talk to people, and I think I will carry back more than just an experience. I think I will carry back also new friends from India. Thank you.